Welcome to video 1 for section 4.2, and here we are going to get into solving triangles when they are oblique, which basically means they don't have a right angle. Whenever that happens, then you need to use either what are called the law of sines or the law of cosines, and it all depends on what information is given. If you are given two of the angles and one side, whether it's angle side angle or angle side, it doesn't really matter. You will use the law of sines. If you are given two sides and a non-included angle, which form the abbreviation SSA, or even easier is ASS, then you can use the law of sines as well. However, if it does turn out that you know two sides and the non-included angle, ASS, then you need to be careful because you do need to look at what is called the ambiguous case. And so here we go with example number 1. Solving the triangle simply means finding the missing pieces. And so in this particular case, angle C is 75 degrees, angle A is 45 degrees, and side B is 4. And here we have angle side angle, and so this is a straightforward case and we can use the law of sines. Now the law of sines says take sine of an angle, I'll start with sine of A, over its opposite side. In this case it's little a, we don't know what that is going to equal the sine of angle B over its opposite side, which is going to equal the sine of C over its opposite side. Now it doesn't take much to realize that B can be easily calculated as 180 minus the sum of the other two angles. Or in other words, 180 minus, let's see, 120, which will mean 60 degrees. So B is 60 degrees. So we can put that value in rather quickly. And so what we're going to do is we're going to have two different proportions. We're going to take this ratio here, compare it to this one in this proportion. Then we'll take this ratio with this ratio and in that proportion, and that will allow us to solve for A and C. So solving for A here, we would get A, the sine of 60 degrees, equals 4 times the sine of 45 degrees. And then solving for A simply means divide both sides by the sine of 60 degrees. And do an approximation. Now when we do this, the general rule is this: round all angles to the nearest degree and round all sides to one decimal position further than the most precise one that's given. So here we have 4. There's 0 decimal places, so we're going to round 1 beyond that to 1 decimal place. And so we just do 4 sine of 45 degrees divided by the sine of 60 degrees, and we get 3.3 as an approximation. And so we'll just put that in our triangle, 3.3. Now that's missing is C. Now I'm not going to use 3.3 here because this is a rounded value. Don't really like to use this because it's calculated, but you know what, we really have no choice. So we're going to take this ratio compared to this one to solve for C. Doing cross products, we're going to get C sine of 60 degrees equals 4 sine of 75 degrees. And solving for C, we just divide both sides by the sine of 60 degrees. And we get this value. 4 times the sine of 75 degrees divided by the sine of 60 is equal to 4.5, more or less. And so solving for this triangle, all of the missing pieces are now shown. Okay, let's take a look at the second group. The second group says Two sides and an angle are given, which means since we are in the law of sines section, they will be the two sides and none included. And we must use the law of sines in this, but this is what's called the ambiguous case. Now, regardless of what happens, when you're given a triangle and you've determined, oh, I've got two sides and a non-included angle, I don't care what the problem says. I would like you to set it up in this way because it's just going to be a whole lot easier to do so. I like to make my triangles A at that angle, B at the right angle, or the angle on the right, and C at the angle at the top. Now, regardless of what it says in the problem, whenever you have an angle and the side opposite, let's make those the A's. So angle A in example number 2 is going to become 49 degrees, even though it says B is 49 degrees. That's okay, I don't care. So since angle B is 49 degrees, little b is going to actually come over here where little a should be, and that's going to be 9. And you want to set this up because of the next step. Then the only missing piece, the other side, I don't care what it says in the problem, it will always be little b. Then what we need to do is we need to calculate a value called h, which actually represents height, but what it's going to be is h will always be b, in this case 7, because from now on we're not going to look at the problem given, we're going to look at our drawing here. B is 7 sine of a, which equals approximately 7 sine 49 degrees is 5.2 or 5.3, and actually you only have to take it one decimal place. Now what we have to do is we have to ask ourselves, and all of this is shown on 261. First question is A less than H? Well, A is 9 and H is 5.3. A is not less than 5.3. Then we ask, is A greater than or equal to B? Is A greater than or equal to B? In this case, the answer is yes, so that means there is one triangle, since A is greater than or equal to B. There is one triangle. And then finding it is no different than what we did up above. So I'm going to set it up this way. Sine of 49 degrees over the side opposite is 9. The sine of B over 7. This must equal the sine of C over little c. So I'm going to use this ratio with this one to find B. Doing cross products, we get 9 sine of B equals 7 sine of 49 degrees. Solving for B, we're going to divide both sides by 9. And then take the arc sine of both sides. And so the arc sine of 7 sine of 49 divided by 9 is equal to, and since this is an angle, I'm going to round it to the nearest angle, unless we're told otherwise. That is 36 degrees. Now, we might be told otherwise if the problem gives it. You know, if A in this case would be 49.2 degrees, then we'd take it to the nearest tenth of a degree. So now we have angle B is 36 degrees. That makes angle C pretty simple to calculate. So angle C will be calculated as 180 minus whatever 49 plus 36 is added together. Well, let's see, minus, is that 85? Which equals 95. So C will be 95 degrees. Now we can take this ratio with this ratio and solve that particular proportion. Doing cross products with this ratio and this ratio, we get C, sine of 49 degrees, equals 9, sine of 95 degrees. Solving for C, in other words, dividing both sides by the sine of 49 degrees, and getting an approximation to the nearest tenth. It'd be just 9 sine of 95 divided by the sine of 49 is equal to 11.9. We have found the final missing piece, and that is all there is to that particular problem. There was only one triangle. If there's two triangles, we would have a little extra step to have to do here, but it's pretty quick. Once you find that first triangle, the second one's a little bit simpler to find.